What is the biggest misconception about the industry that you're hearing that you would like to address?
I think the most common misconception that is often portrayed in communication in the news outlets quite a bit is this whole idea of you can first is that people simplify it a lot. So there's this notion of in quantum mechanics or in the quantum computing side of thing, you can just try all possible solutions to this problem that you're trying to solve in parallel. So you just solve for all possible solutions and then you pick the best one. That is simply just not true. I think that's the most common misconception, which we hear quite often.
What's the most exciting risk you've taken with your career pursuing in quantum computing?
I would say that the field is in its nascent stage. Even though there is so many big groups, research groups working in this area, it has not been concretely proven even from a theoretical standpoint that using quantum computing for the problems that we are usually interested in is going to sort of give us a speed up. One is the theoretical guarantees on whether we will see a speed up, and second is the practical realizations. I think it's really important to get the foundations strong. Luckily, the existing undergraduate curriculum is actually very well suited for this. But I would say like linear algebra would be sort of step zero. And luckily, that's covered in most of the undergraduate curriculums in STEM programs, so math, physics, computer science, engineering. And quantum computing, like even though someone might make it sound that, anyone can get in and it's very easy, all you need to do is basics of coding, that is simply not true. If you want to make any good progress, you would need to know the foundation, which, as you mentioned, math, physics, and even computer science. When I say computer science, I don't mean just coding, right? Like we are in the era of GPT, so I don't think coding is that much required now. But I think what you do need is strong foundations in algorithms or like these, and these are covered in undergraduate curriculum. And I think time has come that if this field as it progresses, I think more people will start hopefully focusing back on foundations, which I think is very important, because without that, you are essentially just writing code, but you don't really like know what you're doing in a way.